Alright, today I'll be going over LeetCode 347 top k frequent elements. Given an integer array and an integer k, return the k most frequent elements. You may return the answer in any order. So when we look at example 1, we have an input array called nums that contains 3 counts of 1, 2 counts of 2, and 1 count of 3, and k equals 2. So for this example, it wants us to return the k most frequent elements. This case is going to be the 2 most frequent elements from this array, and the 2 most frequent elements in this array are 1 and 2. Thus our output is going to be an integer array containing the values 1 and 2. Some constraints are that k is in the range 1 and the number of unique elements in the array, and it's guaranteed the answer is unique. So the first approach I took is to utilize a hash map with integer as a key and integer as the associated value, because a hash map is going to allow us to keep track of the frequency of a given value in the nums array. And so the first thing I did was populate the hash map by iterating through the nums array, and we would add each value from the nums array as a unique key in the hash map. And if we contain a given number multiple times, then we will just increase its frequency by 1 each time we encounter it. And the next step I took is I utilized an array list to keep track of the order of the elements and their frequencies, so that it would be easier to take the k most frequent elements later on, because it's going to be easier to iterate through an array than it is a hash map. So I created an array called frequency that's going to contain lists within the array. And the reason why the frequency array, its size is going to be 1 greater than the length of the input array, is because this frequency array, how it works is that each index is going to represent a given frequency, and the values that are within that index are going to be the values with that frequency. So if we look at example 1, we see that 1 has a count or frequency of 3. Thus, in this frequency array, we would put the value of 1 into index 3 to represent that 1 has a frequency of 3. And the reason why the size of this frequency array has to be 1 greater than nums.length is because we have to consider the case where if we're given an input array where essentially the entirety of the nums array contains one single value. For example, if we have an input array that contains the value of 1 6 times, we're going to need to put the value of 1 into index 6 of the frequency array. Now, if we made frequency the same size as nums, there would be no index 6 available. It would go out of bounds, because in this example here, where we have 6 counts of 1 from the input, that's going to be indexed from 0 to 5. And so if our frequency array was also indexed from 0 to 5, there would be no 6 index for us to put the value 1 into, which is why we need to make the size of frequency 1 greater than nums.length. And the next step I took was, since this frequency array contains lists at each index, right now everything in there is null. So we have to go inside, iterate through frequency, and at each index instantiate a new array list. And so once we have frequency set up with all of the array lists, we can start iterating through the hash map and placing each number with its count into the frequency array. And so how I did that was I iterated through the key set of the hash map, and I grabbed the value associated with each key, because the value associated with each key is going to be the count associated with each number. And so what I did was, once I had the count, we know what index to put it into in the frequency array, as the index of frequency is going to represent the counts. So we're going to go to the index of the frequency array and then add the given number to the array list at that index. The reason why we're using an array list at each index of frequency is because we could have cases where multiple numbers or multiple elements have the same frequency and need to be put at the same index. And so once we have this array frequency like fully populated, we're going to have to iterate through frequency and take the k most frequent elements. Now, the reason why we used an array of frequency to keep track of the k most frequent elements is because it's going to be easy to iterate through frequency and take the k most frequent elements. And so the first thing we have to do here is, instantiate another array like res, short for result, because we're going to be returning an integer array. Now this integer array is going to be of size k because we are going to return k most frequent elements. In example 1, we're returning the 2 most frequent elements, thus the output array that's being returned is also going to be of size 2. And I used a for loop to traverse the frequency from high to low. So essentially we traversed it backwards. And the reason being is because since we want to take the k most frequent elements, we have to remember that this frequency array is ordered right now from least to greatest. So the values, the indices, the highest indices at the end of frequency are going to represent the numbers with the highest frequency. And since our task is to take the k most frequent values, we're going to start at the end of frequency and essentially keep iterating until we've been able to take the k most frequent values. So we start from high to low, and then since each index in frequency represents its own array list, we have to use another for loop to iterate through each sublist, and from there we're going to be able to assign the number or values elements within the sublists and assign them to their proper index within the returned integer array. And then we have this index variable here that starts at 0, where each time we are able to add a value to the result list, index is going to increment by 1. And if index ever is equivalent to k, meaning we've added k elements to our result list, then we are able to just return result. And let's run this code here. Alright, we see we passed the test cases. Now, the time complexity of this program is going to be big O of n, and one might assume that the time complexity here is going to be O of n squared due to the fact that we have a nested for loop here. However, the reason why it's not O of n squared is because this inner loop here is not going to perform more than n iterations in total across all iterations of the outer loop. Meaning, so this outer loop here is going to iterate n times, where n is going to be the number of elements within frequency, aka frequency's length. So we're going to iterate n times. But this inner loop here is going to iterate through each sublist. However, sublists within frequency can be empty. And if the sublists are empty, then this inner for loop is not going to run. And then once this for loop encounters an empty array list, it's going to skip this body, then it's going to increment the outer loop, and it's going to check again, does the sublist have elements? If not, we're going to skip. And we're going to keep doing that until we find a non-empty array list. And then we can start executing the body here. So it's not going to be of O of n squared because this inner loop here is not going to run every single time. And thus the time complexity of this is going to be big O of n, linear time.